is if you're not interested in solar, just pass it on. If you don't get one and you are interested, put your name on this piece of paper and I will email you that plus everything else that I have. And it's more than you could read in a week. So give me a baseline of what you already know. How many of you already have some kind of solar panel thing, device, charger, controller? Okay, so it's not non-existent. That's good. How many of you have a complete setup that goes from panel to charger to battery back to an inverter that you can use an appliance? Okay, a handful. Less.
If
Okay.
it's in the box, does that count?
Say that again.
Still in the box.
It's still in the box? No. It's better than not at all, but I don't know.
No box.
I started looking into solar stuff probably about 8 months ago because I'm a mechanic and I use various power tools. I usually use cordless power tools, but I can't recharge them while I'm on site, and if I run out of batteries, you see where that becomes a problem. So I wanted enough solar energy where I could put a solar system actually on my van or in my trailer where I could recharge my cordless tools. And that's where it started. So today I'm gonna tell you what I found that will give you a decent emergency bare necessity solar system for under $1,500. That's what I'm trying to get to. There's a lot of different ways to go about it. It all depends on what you're going to use it for, how much power you expect to get out of it, what kind of duration you want to get out of the system, aka the batteries. So if you have any questions, try to wait till I'm done with one point and then ask me all at once because I might very well cover what you're getting ready to ask me in the next 5 seconds, like that.
May we have your email address so that
Yes,
we can email you questions?
it's on that sheet.
Oh, it is.
If the sources that I'm about to give you aren't enough that I send you, there's nothing you can ask me that I'll know, because everything that I know is going to be in my report that I am handing out and over those sources in.
If you email that to me, I'll email it out to the whole group.
Or we can do that. And you can just click. I put hyperlinks, which is clickable email stuff. I put hyperlinks in my report, so you can read through my report when you email it and just click it and it'll open up the page. All right, some basic vocabulary. You've got volts, amps, amp hours, watts, watt hours. What is a solar panel? What is a battery? What is a charge controller? What is an inverter? Those are the basic components of a solar system. Panel, battery, charge controller, inverter. That's the basics. You don't really need to know a whole lot of the technical stuff about volts and amps. The biggest number that you need to know is watt hours. SCE&G uses watt hours to report how much electricity you burn in your house. It's the standard for how much electrical energy you're spending. Just to give you a ballpark, in hot summer months at my house, which isn't very efficient for insulation, I use about 72 kilowatt hours a day, which is 72,000 watts. That's a lot. I don't know, I'd have to look at your electric bill to tell you what you use, but it's probably not that far off. In the winter, when I'm not using the air conditioning, which is where a lot of that energy comes from, I'm only using about 33 kilowatt hours, which is 33,000 watt hours a day. And that's because the heater is running and it's gas powered instead of the air conditioner. So just to give you an idea of the numbers. There's 3 kinds of panels that I'm going to tell you about. There's stuff that's on the market. There's stuff that's in R&D still. There's stuff that's better. There's stuff that's worse. But the 3 main kinds are amorphous, monocrystalline, polycrystalline. All of those are photovoltaic panels, PV panels. You're going to see that every time you read about solar stuff. You're going to see PV. It means photovoltaic. Panels that take sunlight and turn it into electrical energy. An amorphous panel is the kind of panel that you'll get at Northern Tool. They're real thin, they're real light, they're also very cheap, and they're also not very efficient. Just to give you a ballpark, this is about the size of a healthy commercial grade monocrystalline or polycrystalline panel. 60, I think the average one is about 65 inches by 44 inches. Okay, a panel about that size will make about 250 watts on average. Okay, that's monocrystalline or polycrystalline. Those are the 2 standard types. You're going to see that over and over again. You won't see anything else really for sale. The amorphous ones, you'll only see at Northern Tool because they want to sell something for 24 bucks. An amorphous panel this size will make about 60 or 70 watts. So they're literally 6 to 8% efficient, and a monocrystalline or a polycrystalline panel may go up to about 20% efficiency. That percent number is a representation of how much energy it will harvest in a given area. The sun, full sun, no clouds, no rain, no trees in the way, no shade, 1 square meter is 1,000 watts. So a solar panel is designed to catch that, and they're 20% efficient. So out of that 1,000, you're gonna get 200 watts out of it. Like I said, they're working on all kinds of technologies, and they're talking, 30, 35-ish for some of the really fancy ones now, but it's all about cost, mostly for the energy. They have to make something they can sell, and for a 35% panel, you're gonna pay, it's like $3,200, so that's why they don't sell them. Batteries. Don't worry about that number, don't be scared. They're not that much. Batteries, there's a couple of different kinds, but the only two that you're really gonna hear about considering solar stuff or PV arrays are AGM, which is absorbed glass mat, and flooded lead acid. Don't get confused with those words, they don't mean a whole lot. It doesn't matter what's in there. What you need to know, and what my solid opinion is, as well as most of the sites I read about, is flooded lead acid batteries are the standard. There's a lot of different kinds of flooded lead acid batteries. The ones you have in your car are of the lowest quality. They have very thin plates. They're not designed to be discharged and recharged, and they're not designed to be used for, a power source. They're designed to stay right at about 75 or 80% in your car, and that's it. The better flooded lead acid batteries are the kinds you'd see in golf carts, electric golf carts. It's the exact same thing you'd use in a solar panel array. They have obviously varying qualities, and you get what you pay for with those. The way they measure batteries, and this is one of the most important things I want you to learn, so stick this to your head. The most important thing about any particular battery is its amp hour rating. Okay, they're generally measured at a 20-hour rate. And just for example, on that sheet I passed around, the basic bottom of the line renewable energy or solar system battery is going to be about 225 amp hours at 20-hour rate. What that means is that it's got 225 amps in an hour of time. Okay, now the batteries are all in different voltages too, but the only thing you need to do with the numbers that you see on the back, stop me because I'm making a lot of assumptions in my head here. I know the numbers get funky. You multiply the amp hour rating of the battery times the voltage, and that gives you watt hours. Okay, so to simplify it, if you've got a 200 amp hour battery, and it is, I'm going to say 10 volts, there aren't 10 volt batteries, but just to simplify the math, 200 amp hour battery that's rated at 10 volts, that's going to give you 2,000 watt hours. Volts times amps equals watts. That 2,000 watt hour number is what you're going to work with in deciding how much power that battery is going to give you. You've got a battery, one battery that's 2,000 watt hours. That means you can run one appliance that uses 2,000 watts for 1 hour, and it will completely discharge the battery. Okay. Okay. So, how many have those sheets gone around? I'm hoping I got a couple eyes on these numbers. Are they all spent?
Yeah,
There are a lot more people here than there usually are, so I didn't print it. I ran out of paper too.
You're very popular.
Well,
Yes.
that's solar stuff. So the batteries that I would recommend using are actually about that rating, 2,000 watt hours. Let me go back to vocabulary a little bit. I mentioned flooded lead acid. You're going to hear a lot about marine deep cycle batteries. You've heard that before, marine batteries. I already told you about the difference between an auto battery and a deep cycle battery. Deep cycle batteries are exactly that. They're designed to be discharged and recharged. No battery, and it doesn't matter if you're talking about flooded lead acid or lithium polyphosphate or absorbed glass mat, no battery is designed to be discharged completely and recharged constantly. The less you do that, the better. And that's certainly true for the flooded lead acids as well. A deep cycle battery is, I would say, the only option for solar power, because you are going to be using it and you are going to be recharging it. So you don't want to use a car battery, although you can. You don't want to because it won't last. I'm a mechanic, and you can probably discharge at a 50% rate. You can use half of the battery in a car battery, maybe 5 or 6 times, and it's done. and you don't get any more out of it. So